Hi, hello everyone. I welcome you all. So here we are going to discuss about what do you mean by deep learning, introduction of deep learning, their overview, how deep learning is working, then applications of deep learning. So first, what do you mean by deep learning? Deep learning is a subset of machine learning. It enables to handle a large amount of data set. So come, let's go discuss about the deep learning and its introduction. Deep learning models can automatically learn the features from the raw data itself. So here, this artificial intelligence is the ability, a capability of a machine to imitate a human behavior. Machine learning is a subset of artificial intelligence that makes a model to learn the features automatically. After learning it, improve the experience. Deep learning comes under the subset of the machine learning. So sometimes in case of machine learning, when we are providing a large amount of data, means it can't able to handle the complex patterns. Their algorithms are mainly inspired from the human brain. Why do we need this deep learning algorithm? So number one step is that the machine learning algorithms can't able to handle a large amount of structured data. Deep learning able to handle this structured, either structured or unstructured data. It helps to process a huge amount of data. Second one is that it can able to handle a complex algorithms. Here we are going to use many mathematical expressions from the probability, linear algebra, statistics, etc. Implementation becomes somewhat complex. For that we are in need of an algorithm. So this deep learning helps to overcome those issues. The third one is that, so in case of machine learning algorithm, when the amount of data gets on increasing, the performance becomes less. So to overcome these issues and to improve the performance of the model, we go for deep learning algorithms. The fourth one is extracting the features. So in case of machine learning models, the feature extraction is a separate step. Then after performing the feature extraction, we go for the classification algorithms. But here in deep learning algorithm, when we are providing a large amount of data, automatically it analyzes the input and extracts the features from the input data. You can see how image recognition is working with the help of deep learning. Here these are some images of the dogs that we are provided. These are various types of dog. Providing with that data to the artificial neural network. Then after providing the data, some new images of animals have been provided. Then we can identify which one is dog. How this artificial neural network identify the images. So this is a training data, the data which we are providing to the neural network to train the model. So this is how the features are extracted. So this is the image of a dog, means this is how they identify the features. The classification is done. Then we identify which one is the dog. First, what do you mean by a neural network? Actually, this neural network concept is inspired from the human brain. So it receives the input, process the input, and then providing the output. So here this dendrite that represents the input and cell nucleus that represents the node, and this axon represents output. Then these snaps are the divisions. Here you can see that n number of inputs are given and it is represents as s1 x2 till xn. So this weight represents the connection between that input and that neuron. W1 W2 that represents the weight, and the output is predicted finally. We compare the biological neuron with this artificial neuron. So this is a dendrite. So here this dendrites that represents the inputs, and this cell nucleus that represents the nodes, and this axon that represents the output, and that snaps that represents the weights. The first step of a neural network is to calculate the weighted sum of the input and the bias. Okay, so here you can see the summation of I1 to n values. So W1 to W2 to Wn. So n number of values. So we can represent as I equal to 1 to n. So W1 product of x1. So this is a weight we are going to product this weight with this input value, then adding the bias function. The second step is to pass this calculator the weighted sum as the input to this activation function to generate the final output. So now we can see what do you mean by this activation function and what are its functions. The types of the activation function, we can see various types of activation function. The number one is sigmoid, then threshold and rectifier linear unit, and final one is hyperbolic tangent function. Now we can see one by one. The first one is a sigmoid function. Here in this graph we have to predict the probability as an output value. So it exists between 0 and 1. So we can calculate this function with the help of the formula 1 divided by 1 plus e to the power of minus x. So this x represents the input value, and this is how we calculating the sigmoid function. Here the x-axis is that transfer function value, and this y-axis that represents that activation function. The second method is threshold function. So here we can fix a threshold value. Particular value is greater than the threshold means we can take it as 1, or otherwise we can take it as 0. Y value is greater than a certain value means the function is activated, or otherwise it is not activated. The third one is rectifier linear unit function. Is the most widely used method. Here you can see that a maximum value can be taken. Here it gives an output of x. If the x is positive, or otherwise we can take it as 0. The fourth type is hyperbolic tangent function. This is similar to that of a sigmoid function, but the range, bounding range, that is between minus 1 and 1, and it's bounded by the formula y of x that is equal to 1 minus e to the power of minus 2x divided by 1 plus e to the power of minus 2x. That x defines the input function that we are giving. Here the range is between minus 1 and plus 1. You can see this activation function. So these are all the input layer. The first layer that receives the raw data. Then the hidden layers. The hidden layers are the intermediate layers that process the input from the previous layers. And final one is the output layer that provides the output of the network. Now we can see how a neural network is working. See how we can identify dogs and cats. If an animal database is given means how we can identify the animal is either a cat or it is a dog. As input we are giving different types of cats and dogs we are providing that represents the x1, x2 up to xn, that the input vectors. Then we are providing the hidden layers. So after the hidden layers we can identify the output. So this is the predicted output. So that is classified as cats and dogs. Total number of hidden layers that are present in a neural network. So that allows them to handle a more complex patterns, nonlinear data. So to process the nonlinear data, this deep learning helps to access the data quickly. We can consider a simple linear network. This is known as a forward propagation. Here after providing the input, we are having W1, W2, Wn as the weights. Then the bias is provided. So this transfer function is calculated. Then this is a modeled output, which means that our predicted output. So this y cap that represents our predicted output, and this y represents the actual output. Comparing these two things, this predicted and the actual output, we can obtain the loss function value. We are proceeding this forward direction, that is known as forward propagation. What do you mean by a backward propagation? This cost function value as 1 by 2 of y cap of minus y the whole square. So this is a cost function. So after finding the cost function, we helps to reduce the error rate. After finding this cost function, we adjusting this weight so as we can predict the output that is near to the actual output. So here you can see that cost value, that is the difference between the neural net predicted output. So this is the predicted output and the actual output. So by making adjustment in these weights, improve the output value. How we are going to train the neural networks. The year of 2006, there is no proper method to train this deep neural network. A vanishing gradient. So this gradient is nothing but the rate at which the cost changes with respect to this weight and bias value. So we have to identify an optimization method that helps to overcome this gradient issue. An iterative optimization algorithm is used to minimize the loss function. You can see that this gradient is like a slope, and this training process is like rolling a ball. Now you can see that when the slope is gentle means the ball will roll slower. When the slope is steep means the ball roll faster. So similarly for a neural network, if the gradient is small means it will train slowly. If the gradient is large means it will train very fastly. Forward propagation for network prediction. Here you can see that you are trained with the help of this input vectors x1, x2 up to xn. Here the weights are identified as w1 to w10. Once it goes for the hidden layers, the values are changes. So w11 to w22. Again, it is given as input to the next hidden layers. Then the weight is again changed to w23 to 26. Finally, we can predict this output value. Various types of activation functions we already seen. We have to apply those activation functions to the hidden layers to denote which feature we have to identify and which one we have to eliminate. So this is we are comparing that predicted output with the actual output. So in case of forward propagation, we know how to identify the cost function to minimize the difference between these two values. In case of back propagation, we identify the cost function, then we are adjusting the weights. Of forward propagation also, we can update the weights and biases to calculate the cost value. Various applications of the deep learning. The number one is that healthcare application. For cancer detection, it plays a major role. So detecting cancer tumors in the human body, this deep learning network helps to identify. Then the robot navigation. With the help of deep learning, we are able to train the robots to mimic the human performance and human task. Automatic driving option is available. We're able to distinguish the objects, people, the roads, and driving options. Without the human interventions, it able to drive safely. Machine translation, automatically it identify one language and translate to another language using a music. But it can take notes of all music instruments, identify the patterns, recognizing the patterns, and after identifying all the patterns, it can able to compose the music. Then coloring the images. So it is a grayscale image. That grayscale image is converted into a color image. Thanks for sticking till the end. Meet you in the next video. Till then, it's goodbye from Vijay.